Right. I get really jazzed up for these kinds of results, working with entire families of functions. Let me come down to earth just a little bit. And I can give you a limit law. So if I'm trying to calculate the limit of some function, which is then raised to the power n, as x approaches a, this is similar to the polynomial stuff that I was just working at. So I need n to be a positive integer. I need limit of the function f of x as x approaches a to exist. Then this is just going to be the limit of the function f of x by itself. As x approaches a, the whole thing raised to the power n. So this is limit law number 6 in the textbook. I can go the other direction as well. So if I'm taking the limit of the function the nth root of f of x as x approaches a, this will be equal to the limit x approaches a of the function f of x. And this whole thing is going to be, I'm taking the nth root of that. So again, I need n to be positive integer. I need f of x to, I need this limit of f of x to exist. And if n is even, f of x has to be a positive function. Okay. So we're getting lots and lots more functions where we can evaluate them just by taking my x and subbing in for the a that it's limiting towards. We've got all powers of x, we've got all polynomials, we've got square roots now, we've got nth roots. We can even do things like taking the roots of polynomials. So if I wanted to calculate what is the limit of the third root of the function 1 minus x squared, as x tends towards a half, well, I can say that's going to be the third root of the limit 1 minus x squared. X goes to a half. So that's going to be the third root of, well, 1 minus a quarter. I just take my value of x, I put it in here. So the answer is going to be the third root of 3/4. Again, not every function lets me to do that, but this is a very happy lecture because these are all functions that we do like. Let's keep going. Now I've been bouncing around. You can follow Stewart's version that he thinks these rules should come in the textbook in section 1.4 again. The next one let's talk about is limit law number 4. This says that the limit of the functions f of x divided by g of x as x approaches a equals the limit of the function f of x as x approaches a. We then divide by the limit of the function g of x as x approaches a. And what do we need for this to happen? We need the limit of f of x to exist. This should look like a familiar criterion now. So f of x, limit of f of x needs to exist. Limit of g of x needs to exist. And again, this is as x approaches a. And the limit of g of x as x approaches a cannot be 0. So since my formula here is dividing by g of x, it only applies in cases where my denominator is not tending towards 0. So there is a limitation to this formula. But The nice thing about it is that for any rational function, we can use this formula so long as the denominator is not 0. If I want to calculate what is the limit as x approaches 1 of the rational function x cubed minus 2x plus 7 divided by x squared plus 2x plus 1. That's a nice rational function. There might be some roots on the denominator here. There might not be. It might be irreducible. But the combination of all these limit laws that came before tell me that I can just evaluate and write this is 1 cubed minus 2 times 1 plus 7 as my numerator, and then 1 plus 2 plus 1 is my denominator. Looks like that's going to settle down to be 8 minus 2 is 6/4 or 3 1/2. It's 3 halves.